Almost done with the ionic bonding. In this video, we're going to look at how to write the names of ionic compounds. So make sure that you're looking at your classwork and that you've got your resource library periodic table open. Remember, that periodic table is where we're going to find everything for what we need. Here's our periodic table. We also have the Unit 5 ionic bonding homework packet that we're looking in. Remember, that is the Unit 5 notes and homeworks, pages 1 through 11. Right now, we're going to be looking on pages... This is page 8 of your notes and homework packet. Let's give this a try. Okay, we have a formula, NaCl. How do we name it? The first name doesn't change. We have our metal name, Na. So you find Na in your periodic table. I'm going to make this one a little bit bigger because I can't see it very well. You can hear my children screaming upstairs. It's fine. Na is sodium. So we type in sodium. Cl on our periodic table is chlorine. But remember, just like when you're learning a new language, sometimes the verbs change their ending. So our non-metal, chlorine, we don't keep the ine, we change the ine to an ide ending. Chloride, chloride. Chlorine becomes chloride. Let's try another one. K is potassium. 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 The first word never changes, but the second word does. S is sulfur. Sulfur. We have to change it to an IDE. So instead of SULFUR, sulfur becomes sulfide. IDE. Remember, anytime you have an INE, it changes to an IDE. Anytime you have an IUM, it changes to an IDE ending. Let's say, for instance, you have oxygen. That becomes oxide. If you have sulfur, that becomes sulfide. If you have phosphorus, that becomes phosphide. If you have nitrogen, that becomes nitride. All of these change to IDE endings. If you have a formula that has more than 2 elements, right? This is Na and Cl, K and S. Look, this has Na and NO3. You think, oh no, I can't write 3 names. Does the middle one change? I don't know. You're looking for families. You're looking for families. So on the back of your periodic table, you can find all of the families. Hello, families. Polyatomic ion. So NO3 is our family. If you want, you can write that in parentheses so that you know that that's where the family is going to be. The family name never changes. You keep the special polyatomic ion name. So that means Na. Na is our regular atom, regular element. Na is sodium. So we type in sodium. And then NO3 we find on the back. We never change this name. So NO3 is nitrate. 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 Let's try another one. NH4 and SO4. Aha! There are 2 families. NH4 is right here. Ammonium. Ammonium. Don't change the name. SO4 is on the back. SO4 is sulfate. Don't change the name. You only change it if it's a regular element. If it's a family, you write whatever name is back there. Sodium nitrate, ammonium sulfate. Now the hard part. If the element is in the D block, remember the D block are our inner transition elements, or in the 4A column. The 4A column does some wacky stuff because if you have 4 valence electrons, do you want 4 more? Do you get rid of those 4? Ugh. So treat the 4A column like the D block, the transition metals. When you see them, you're going to need a Roman numeral. So Cu, when you find its name, Cu, oh, copper is in the D block. So that's our clue that copper is going to need some Roman numeral. We're going to leave it blank for right now. The next one, S is here. Sulfur becomes sulfide. Now we have to figure out the charges. S S is here in the 6A column. That means it wants 2 more electrons. S is going to have a -2 charge, a -2 charge on the S. Because all of these formulas have to be balanced, we know to balance out a -2, we're going to need a +2 charge. The Roman numeral indicates the charge. The charge is the Roman numeral. So that means if we have a charge of +2, our Roman numeral needs to be 2, copper 2 sulfide. Let's try another one. CuCl. Here's our Cu, it's copper again. How do I know whether it's going to need a Roman numeral? If it's in the D block, here's copper. It's in the D block, it's going to need a Roman numeral. So I'm going to leave some space for our Roman numeral. Cl is chlorine, and that becomes chloride. Chloride. Now let's figure out the charge. Cl, we have to do the negative charge first. Cl is over here in the 7A column, which means it has 7 valence electrons. It wants 1 more. So that means chloride, has a -1 charge. To balance out the -1, you need a +1 charge because +1 and -1 balance each other out. This copper has a +1 charge. So that means it's going to have a 1 Roman numeral because that Roman numeral indicates the charge, not how many they are. This one had 1 copper, but it had a Roman numeral 2. This one had 1 copper, it had a Roman numeral 1. How do you figure it out? You got to balance the charge. Figure out what the negative is. Figure out how many positives you need to balance it. Let's look at this one. ZNO. Zn, where's Zn? Here's Zn. Zn is in the D block. So that means that we're going to need to give zinc a Roman numeral. Zinc, something, and then O is oxygen, becomes oxide. To figure out the Roman numeral, we got to figure out the charge. O has a -2 charge. So because oxygen has a -2 charge, the total charge over here has to be +2. Has to be +2. But look, there are 2 zincs here. Because there are 2 zincs, each zinc can't have a +2 charge because then I'd have 2 times +2 for a total charge of +4. +4 can't balance out a -2. So that means something else. 2 times what gives me +2? 2 times +1 gives me a +2 charge. That means each of those zinc atoms has a +1 charge, giving our zinc here a 1 Roman numeral. A 1 Roman numeral. Let's do one more. Make it come back. Our last one here is COSE2. CO is cobalt. It's in the D block, so it's going to need a Roman numeral. So I need cobalt something, and then Se. Se is selenium. 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 Oh, I got to change the ending. Selenide. IUM becomes IDE. All right. Now let's figure out what that Roman numeral is. Se has 6 valence electrons. It wants 2 more. So that means Se has a -2 charge. But there are 2 of them. 2 times -2 means that now I have a total charge of -4. All right, my total charge has to be balanced out. So that means I need a +4 to balance out a -4. There's just 1 cobalt, so that 1 cobalt takes on all of that charge. So cobalt becomes cobalt 4. That's how you draw a Roman numeral 4. That's as big as the Roman numerals as we're going to get. Cobalt 4 selenide. Hopefully this helps you figure out the formulas. I'm going to do another page or another video of how to do them forwards and backwards. Good luck, everybody.